In this video, let's integrate x into cos inverse x upon square root of 1 minus x square. This question looks very complex, but in fact it is very easy. To understand this in a little detail, let us first rearrange the terms a little bit. So I can write this as integration of x upon square root of 1 minus x square cos inverse x dx. Does this look a little familiar to you? We have solved this similar problem in one of our other videos, but there instead of cos inverse we have sin inverse x. I will put the link of that video in the description box. You can check it out. Now I want to do one more modification in the problem before we start solving. I want to somehow get a 2 here. Since we have x square, if I differentiate it, I'm going to get 2x. So to do that, I'm going to add a 2 here. Since I'm adding a 2 here, I'll have to add a 2 here as well. Since I have minus x square, I'm also going to add minus signs in both places. And with this, let us start solving our problem. So my problem has now changed to this thing. And here also you see that we have two functions which are there in multiplication. One of them would be minus 2x upon square root of 1 minus x square, and the other one would be cos inverse x. And whenever we have two functions in multiplication, we integrate them by using integration by parts. And as I have mentioned earlier, integration by parts depends on selecting the correct first function and second function. First function has to be easier to differentiate, and the second function must be easier to integrate. Here we see that cos inverse x would be easier to differentiate, so I'm selecting cos inverse x as my first function, and this gives me second function as minus 2x upon square root of 1 minus x square. I also know that integration by parts tells me that integration of two functions f of x into g of x can be calculated as first function, that is f of x, into integration of second function, that is g of x, minus integration of g of x into differentiation of first function and dx. Let us put the first function and second function in this formula and start solving. I get x into cos inverse x upon square root of 1 minus x square as, so this term will come outside. So this term will come outside, so I can write this as minus 1 by 2 and then integrate the rest. So I write first function is cos inverse x into second function, that is integration of minus 2x upon square root of 1 minus x square dx, minus integration of minus 2x upon square root of 1 minus x square dx into differentiation of first function, which will say d by dx of cos x dx. Now if you look at this, we need to find out what is the integration of minus 2x upon square root of 1 minus x square, and we also need differentiation of cos inverse x to proceed further. Let's call this equation as equation number 1 and find out these terms so that we can proceed further. So first let us perform the integration. Now integration of minus 2x upon square root of 1 minus x square. This we have performed in a different problem. You can check it out. Here we are going to use another method of integration, which is called integration by substitution. This method of integration is very interesting. We substitute part of the function and get the rest by differentiating it. So here let us take 1 minus x square as y. When you differentiate it, you get minus 2x dx as dy. Isn't it interesting? So I get the whole numerator as dy and denominator will be square root of y, which is very easier to integrate. So I can write this now as dy upon square root of y. The square root of y can be written as y raised to 1 by 2, and since it is in denominator, I will add a minus here. So I get y raised to minus 1 by 2 dy. This can be integrated using the identity x raised to n dx. So integration of x raised to n dx is given by x raised to n plus 1 upon n plus 1 plus c. Now here the value of n is minus 1 by 2. So I can integrate and get minus 1 by 2 plus 1 upon minus 1 by 2 plus 1. So this can be written as 2 into square root of y plus c. Now I can replace y with the value of x and get 2 into 1 minus x square plus c. I hope now you understand why we have added the 2 in the beginning of the question. So here we added a 2, right? Here we have added a 2. We have added this so that our integration becomes easy. So let us call this equation number 2 and calculate d by dx of cos inverse x next. So d by dx of cos inverse of x can be calculated very easily using the identity. Differentiation of cos inverse of x is minus 1 upon square root of 1 minus x square. Let's call this equation 3. Next, I want to put 2 and 3 in 1. And let's see what do we get. So I get integration of x into cos inverse x upon square root of 1 minus x square dx as minus 1 by 2 into first function, which is cos inverse of x, into integration of this thing. That is, using 2, we can write as 2 into square root of 1 minus x square minus integration of second function, which is 2 into square root of 1 minus x square into differentiation of cos inverse x. So using 3, I can write that as minus 1 upon square root of 1 minus x square and dx. Now we need to perform integration one more time so that we can get the answer. So here if you see closely, you will see that this numerator and the denominator are the same terms. So I can actually cancel them. So I will be left with minus 1 by 2. This term I can write as 2 1 minus x square cos inverse x minus, so integration of 2, let me write outside integration. So here I have just minus 1. So this minus and this minus will become plus, and I'll be left with only dx. Now I can just take this 2 common. So I will get minus 2 upon 2 into square root of 1 minus x square cos inverse x plus integration of dx is x and plus c. Now I can cancel this 2 and this 2 and write the answer finally as minus into square root of 1 minus x square cos inverse x plus c, and this is the final answer. So integration of x cos inverse x upon square root of 1 minus x square is minus square root of 1 minus x square cos inverse x plus c. Wasn't that easy? So just check how we have done it. We have first modified the question so that it becomes easier for us to solve it. We have seen the denominator, and this gives me an idea that if I add a 2 here, my question will become very, very simple. So look at the question very carefully before solving and think of ways how you can modify it to your advantage. Keep practicing, and let's meet in the next video.